So let's come back to ninth one. Okay, so let us come back to ninth one. So what is ninth one is this. Okay, because that is homework, I will remove that gap. Okay, so we want to find the Fourier transform of the ninth signal, which is defined as d by dt of x square of 3 to minus 1. This is easy problem, but we'll do that. Okay, so because there are so many operations involved, we have to split. So let us define first signal as x91 of t, which is x of t minus 2. Correct. So first operation is time shifting, so we will do that. So this fellow will have x91 of j omega as the Fourier transform. Because it is time shifting property, you will get e power minus j2 omega x of j omega as the Fourier transform. Next, we have to find Fourier transform of x of 3t minus 2. So we will define that as new signal x92 of t, which is nothing but x91 of 3t. Correct. In x91 of t, replace t with 3t, you will get this. So this fellow is which property? X91 of 3t, that is time scaling property. So that is x92 of j omega, which is equal to 1 by 3 x91 of j omega by 3. So this is equal to 1 by 3 x91 of j omega is here. In this you replace omega with omega by 3. So you will get e power minus j 2 omega by 3 x of j omega by 3. That would be the Fourier transform of which signal? X of 3t minus 2. Correct. So this is our x of 3t minus 2. Now let us define third intermediate signal, which is x93 of t, which is nothing but x92 square of t. Correct. So what is this equal to here? This is equal to x square of 3t minus 2. So this fellow will have what as Fourier transform? X92 square of t. This is multiplication in time domain. So what should happen in frequency domain? Convolution. So convolution of which functions? x92 of j omega with itself. We'll get x92 of j omega convolved with x92 of j omega. Okay, right. So this should be equal to how much? 1 by 2 pi. Okay, so this flow is multiplied with 1 by 3 e power minus j2 omega by 3 x of j omega by 3. Okay, and this fellow is convolved with itself. So you will get 1 by 3 e power minus j2 omega by 3 x of j omega by 3. Okay, yes. So we are not done still, right? So what is that we have to do? We have to find finally the Fourier transform of which signal? So our x9 of t, yeah. Yes, so Fourier x9 of t is what? Finally, that is nothing but d square by dt square of x93 of t. Okay, which is nothing but d square by dt square of x square of 3t minus 2. Okay, so this fellow will have what as Fourier transform? D square by dt square of x3 of x93 of t will have, because you are differentiating in time domain 2 times, in frequency domain you will get j omega whole square multiplied with x93 of j omega. Okay, so this fellow, this final term here, whatever we got above, this is our x93, right? This is nothing but x93 of j omega. So what is that you have to do? So this would be again equal to minus omega square multiplied with which fellow? This whole thing will come here. So that would be the Fourier transform of this whole signal. Okay, right. So it looks complicated, but if you do it by divide and conquer, it would be easy. Okay, so let's move on to the 10th problem, which is this one. Okay, x10 of t is given to be x square of 2t convolved with x of t by 2. Because this is easy, I will give this as homework here. That's easy problem. So let us take that as homework. So let us do the 11th problem. Okay, so let us do the 11th problem. Okay, so what is 11th problem? That is e power minus jt x of t minus 1 convolved with e power jt x of t plus 1. So we will do step by step. Okay, so x of t minus 1 will have x of j omega multiplied with e power minus j omega as the Fourier transform. So e power minus jt x of t minus 1 will have what as Fourier transform? X of t minus 1 will have this as usual. Let us split, that would be better. Let us call the shifted version of x of t as x1 of t. So this fellow would be our x1 of j omega. So e power minus jt x of t minus 1 is same as e power minus jt x1 of t. So this fellow will have what as Fourier transform here? X1 of j omega plus 1. So this is what? This is shifting in frequency domain property. So this should be equal to wherever there is omega, replace with omega plus 1. You will get x of j omega plus 1 multiplied with e power minus j omega plus 1. Okay, so with the same argument, we can easily see that. Okay, so this is as far as first signal is concerned. Let us do that for second signal. So let us call x2 of t to be equal to x of t plus 1. This fellow will have x of j omega multiplied with e power j omega, and we call it x2 of j omega. Okay, so next we want Fourier transform of e power jt x of t plus 1, which is nothing but e power jt x2 of t. So this fellow will have what as Fourier transform? Again shifting in frequency domain, you will get x of j x2 of j omega minus 1. Okay, but x2 of j omega is this, so we have to substitute omega with omega minus 1. You will get x of j omega minus 1 e power j omega minus 1. So we got the Fourier transform of these two fellows. Now what is the next step? They are getting convolved in which domain? Time domain, and hence finally what would be the answer? Okay, so we want Fourier transform of the final signal. What is that? E power minus jt x of t minus 1 convolved with e power jt x of t plus 1. So this fellow will have what as Fourier transform? So first fellow we got that to be x of j omega plus 1 e power minus j omega plus 1, and this whole thing is multiplied with so that whole thing is multiplied with this fellow. Who is that? This fellow, right? X of j omega minus 1 multiplied with e power plus j omega minus 1. Okay, so finally what do we get here? This is same as e power minus j omega plus 1 multiplied with e power j omega minus 1. So these two fellows will get cancelled out, right? Is that correct? So minus j omega is gone. Here also you get minus, sorry. So they won't get cancelled out. E power j omega will get cancelled out, not the other one. So you'll get e power minus j multiplied with e power minus j. So that should be e power minus 2j multiplied with x of j omega plus 1 multiplied with x of j omega minus 1. So that would be the Fourier transform of this signal. Okay.